We're going to do day 2 of 11.4, and today we're going to talk about area of regular polygons. So objective, we're just going to be able to find areas of regular polygons. So first we need to talk about different parts of a regular polygon. Remember, to be regular, it means that all the sides are equal. So if you don't remember that, jot it down. All sides, we're going to say congruent. All right, so we have something called the apothem. The apothem is a segment drawn perpendicular, we're going to use the perpendicular sign, to a side of a regular polygon. And so if we look at our picture to the left, we have a regular pentagon and it's inscribed into circle P. And so our apothem here is perpendicular from the center to one of the sides. Then we have something called a central angle. Central angle happens when the vertex of the central angle is the center of the polygon. And that should not be anything new to us. We learned it in chapter 10. We just didn't talk about how to find that actual central angle. The reason why our pentagon is inscribed is because what's the degree measure of that circle? It's 360. And if we want to find the measure of this central angle, which the central angle is here to here, we take 360 and divide it by the number of sides. And remember, in the past we've used n to represent number of sides. All right, so let's just go ahead and label some different things here. The center is our point K. Radius, we have a couple here. We have KG or we have KH. KL is not a center, or I mean a radius, because it does not go to the edge of the circle. KL is actually our apothem because it's the perpendicular one. And central angle, remember angles need 3 letters. Our central angle is here. So G, K, H, or we could label it the other way, H, K, G. And lastly, we need to find the measure of the central angle. And so it's a square, so there are 4 sides. So we're going to take 360 and divide by 4, which ends up being 90 degrees. All right, we have another one just like this. I want you guys to go ahead and find this for this hexagon we have here. So pause the video and then come back. All right, number 3 says find the area of the regular hexagon with sides length of 5. So here we have a side length of 5 centimeters. And in my paper, but not here, it says that this is 8 centimeters. Our apothem is 8 centimeters. So we're going to start off by finding the area of the triangle. Remember, area formula for a triangle is base times height divided by 2. So we're going to take 8 times 5 and divide by 2. 8 times 5 gives us 40. Half of 40 is 20. And we are talking about area, so it's centimeters squared. Now to find the area of the hexagon, if you notice our one triangle, we can duplicate that here and make lots of triangles. Now these triangles are all going to have the same area. So we're going to take to find the area of the hexagon, we're going to take our area of our triangle and times it by the number of sides we have. A hexagon has 6 sides. So we're going to take 20 times 6 and we get 120 centimeters squared. So that's the most basic way that we can find area of a regular polygon, is to actually break it into triangles, find the area of one triangle and multiply it by the number of sides. Now if we look here, area of a regular polygon, this is another way to talk about it, but you actually end up finding the exact same thing as what we just saw. This is going to be a little bit more mathematical for you. So it says the area A of a regular n-gon, so n just means how many sides it has, with a side length of s, is half the product of the apothem and the perimeter. All right, so half the apothem times the perimeter. We could change that. Our perimeter, you see here, s is the length of our side, And we talked about n is the number of sides. So we could say 1/2 the apothem times the number of sides times the side length. Both of these are going to just basically come down to, again, find the area of one triangle multiplied by number of sides. So find area of one triangle multiply by number of sides. And that's going to be our most basic way to do this. So let's just start with finding the area of a regular triangle. Well, remember we said triangle area formula is base times height divided by 2. So let's drop down a height and call this h. If we have a right triangle here, we know that this base here is 4, so half of it's 2. Now you can go ahead and do Pythagorean theorem and find our missing side, our height. All right, so we find that from our Pythagorean theorem, we get a height of about 3.5. So we're going to take our base, and now we're talking about the whole triangle, so our base isn't just the 2. Our base is the 4 times our height of 3.5 and divide by 2. So we end up with 7 feet squared, finding the area of the triangle. All right, so let's make it a little bit more difficult. Here, instead of giving you the base or the height, I'm going to give you the hypotenuse. And so this is where the central angle is going to come into play, and we're also going to throw in some trig here. So if we go ahead and find our central angle, we want to take 360 and divide it by 5 because it's a pentagon. So we find that our whole central angle is 72 degrees. So this whole thing here is 72 degrees. But to find the height and the base, we're actually going to pull out just one triangle. We'll pull this one out and talk about that. So this hypotenuse is 10. And we now, instead of having an angle of 72, we have an angle of 36. We want to find the base and the height. So we can use some trig here. If I start off with finding the base, now I'm looking at, from my angle, I have my opposite and I have my hypotenuse. So opposite over hypotenuse is going to be sine. So sine of 36 equals my base over my hypotenuse. Because x is in the top, we're going to multiply. Go ahead and do that out on your calculator, and let's round to 1 decimal place to find out how long this portion of the base is. I got 5.9, so I'm going to erase my x and put in 5.9. Now you have two options here. You can go ahead and do Pythagorean theorem, or you can go ahead and do another trig function to find us that height. I am going to look at my whole base. 5.9 times 2, we end up with 11.8. All right, so now I'm going to go ahead and find this height. And I'm going to use trig just so we get some good practice and with trig. And so now, in relationship to my angle of 36, I have the adjacent and the hypotenuse. So that involves cosine. And so we put our adjacent over our hypotenuse. So we end up taking 10 times cosine of 36 equals our height. Go ahead, I'll wait for you. And I got about 8.1. So now I have my base and my height for my triangle. So I'm going to take my base, 11.8, and times it by my height of 8.1 and divide by 2. This is going to find me the area of this whole triangle here. But I want to find the area of the whole pentagon. And so there are 5 sides, so therefore there'll be 5 triangles. So I'm going to go ahead and multiply it by 5. Go ahead and doing that, we end up with 238.95 inches squared. So if you wanted to round that to 1 decimal place, the 5 would tell the 9 to round up, and the 9 would tell the 8 to round up. All right, let's go ahead and look here at this regular octagon. This time we're given the height, so we actually only need to find the base. So we're going to just draw in our triangle. So we're going to start off again with finding that central angle. So we take 360 and divide by 8, and we end up with a central angle of 45. Now remember, when we're doing this, we actually are only looking at half of that. So if we draw this out, we have a height of 8, and our angle is half of our central angle, so 22.5 degrees. This time we only need to go ahead and find our base. And so we can go ahead and use our trig function. We have our opposite and our adjacent. Opposite over adjacent for trig functions ends up being our tangent of our angle equals our opposite over our adjacent. So when we do this, we're going to take the 8 times the tangent of 22.5. Pause the video if you need a moment to type that into your calculator. And otherwise, we end up with 3.3 for our base. Now remember, we need to double that to represent our entire large triangle. So now we have our base and our height, and could go ahead and find the area of one triangle and times it by 8 to find the area of the rest of them. So your job is to find the area of the one triangle. So base times height, these two numbers, divide by 2, and times it by our number of sides, 8. We just have one left here, and it's to find the area of the regular pentagon. And again, you're given the hypotenuse for that smaller triangle here. This one's going to be just like number 5. So you're going to do a couple trig functions because you need to go ahead and find both the base and the height. So I want you guys to give that a try. We'll for sure be going through this in class. Have a good day.